Hi everyone and welcome to lesson 3.4. Today we are going to talk more about composition of our rigid transformations. A reminder that our rigid transformations are transformations who have the same shape and size as their pre-image counterpart. And the three that we have talked about so far are reflections, translations, and the most recent one, which is rotations. And again, all of these, even if we do more than one, will preserve the shape and size of our original pre-image. Now, a composition of transformations is when we perform at least two of these transformations in a row. And again, we start this off with our pre-image, right? We have the starting pre-image each time. And then we take that pre-image, and after we transform it once, what's happening is the pre-image is becoming the, in this case, intermediate image. And it's the intermediate image because we have one more, at least, transformation happening. So we need to kind of have that in-between stage. We call that, again, the intermediate image. Now, we also then will have a final image each time, right, which is, again, our final double prime that we have here. And again, we've talked a little bit about this before, but with these, your original pre-image would be labeled with a point like P, right? So we see that up here. We have point P. With the intermediate image, you would give it one tick mark, this one apostrophe, that's prime, and then we would call it double prime after we do the second transformation to that intermediate image. So again, if we are rotating something, a triangle, 90 degrees clockwise, and then we translate it, are the triangles, the original and the rotated and translated triangle, the same size? And the answer is yes. Okay, we know that these are going to be the same size because rotations and translations are rigid motions. So we know that those rigid motions, when we do even more than one of them, will keep preserving the shape of that triangle throughout all of the transformations. Now we also have here a figure, and we are trying to figure out, okay, what would be the final image after we perform these different transformations. So the first one is we're focusing on arrow A is our original pre-image. We are rotating it 90 degrees counterclockwise. That would go this way, and then translating it 4 units to the right. So we're moving it then this way. So that image, if we rotate and then translate, we'll end up with arrow D as our final image on that. Okay, the next one, if we look at arrow C to start, okay, so we're starting down here with arrow C, it wants us to translate that arrow up 8 units, 2 units to the left, and then we are rotating it 90 degrees counterclockwise. So translating it up would make it look like like arrow B, and then a slight translation to the left and a rotation up ends up having our arrow look like arrow. Oops, not B, A, right? Again, B was the intermediate type image. All right, try the last one on your own. Okay, on the last one, we are focusing again, starting with arrow A, and you want to rotate it 90 degrees clockwise this time. So think about, again, clockwise would be this direction, and then translate it 2 units to the right, which arrow would be your final image. All right, now we've talked a little bit about these before, but again, when we are starting off here with our composition, so our original point is A, and it is located at -5, 7. So there's our original point. And they want us to start by reflecting this across our y-axis. So there's our y-axis. So we are 5 units to the left of the y-axis. We will end up being 5 units to the right with our intermediate image, again, the A prime, which is going to be at +5, 7. Now the next piece is they want us to do a 90 degrees clockwise rotation. So reminder, when we do 90 degrees clockwise, that's the same thing as 270 degrees counterclockwise. So we would take, okay, 90 degrees clockwise, we would take, our rule would be, again, switching the x and the y values, but our value now becomes, of the x becomes negated. So we take our intermediate image, we flip the order, it's now 7, 5, and again, we're going to change the sign though, the 5 now becomes negative. So when we go 90 degrees clockwise, we should end up at 7, -5 for our double prime. And again, that makes sense because clockwise would put us down that way. That image makes sense. On the next page, on the back page, we have another example. This time we are moving a whole triangle. Okay, we are starting with triangle TUV, and TUV is first being reflected across the x-axis. So here's our x-axis. And again, we are reflecting each of those points. So T was 4 units below. T prime is now 4 units above. U was 2 units below. It's now 2 units above. V was 5 units below, it's now 5 units above. So here is our intermediate image. T prime, U prime, and V prime are located at 0, 4, U prime was at 3, 2, and V prime is at 4, 5. Now our final image is going to come from then a translation, in this case to the left 5 and down 3. So we're going to take each of those points and move left 5 down 1, 2, 3. So here's T double prime. And again, we're taking the intermediate image points to do this. V goes 1, 2, 3, 4, 5 to the left, down 1, 2, 3. And then finally, U goes to the left 1, 2, 3, 4, 5, down 1, 2, 3 for U double prime. So we end up at -5, 1 for T double prime. U double prime is at -2, -1. And V double prime is at -1, 2. All right, now our final question of the day is having you try, all right, this composition. Again, we have point A, which is starting at 2, 1, and you want to first translate to find A prime, and then finally reflect across the x-axis to find A double prime. Thanks everyone for watching. We'll work more with these in class.